as you guys are aware, like spanning tree protocol, you know, when switches are connected with in a redundant redundant link, so there is a chances of occurrence of the loop. So let me type here the operation of the link STP, which is very important to understand, because in the Encore lab in the CCIE, this is very important to understand. Normally troubleshooting also happens at the spanning tree. So there is many flavors of a spanning tree protocol. So let me talk on each and every one. So let's guys, you can see the screen on the switches, and each switches is connected with dual link, which is, we can say it's a redundant link because two links are connected to all switches. This means this switches is designed in the redundant manner, and whenever switches are connected in a redundant manner to provide a redundancy, then chances of loop occurrence. To make a loop free path, switches are default enabled with spanning tree feature. Default mode of spanning tree protocol in all switches are PVST. Let me power on all the switches. So I will take the theory as well as I will show the practical. So which makes good learning for us to understand the spanning tree protocol. I'm just powering on all the switches. So what is happening as soon as we power on the switches? As I said, default STP is pre-default STP is configured in the switches, and they will start to calculate the root bridge. Okay. Now let me show you the access of this spanning tree protocol. Default Cisco PVST. It tried, sorry, it finding a root bridge which who can control all STP services when running in switched network. Let me see if the switch is power on. Okay, switch 2, switch 3, switch 4. Okay, so the switch is powered on. As I said, switch is powered on, and switch is a layer 2 device that everybody is aware. So once the redundant topology created in the switch, chances of loop can occur, but default mode is PVST. Let me show you. I'm so it's a plain configuration. There is nothing configuration in the switch right now. If I do so spanning tree, you can see spanning tree enabled protocol IEEE, which is in the configuration of iOS of switches. If you see, there is a mode is default is PVST. So each switch, if you go on each switch, everything is pre pre-configuration, the predefined configuration of spanning tree, and that's how this spanning tree worked actually. But so once spanning tree is developed to ensure that logical path between all destinations on the network must created. So as I said, how does the how does the STP works in the switches environment? First, it find the root bridge ID election. Let me note down here. So what spanning tree is doing is run the spanning tree algorithm. With the help of switches, create a topology database which is identical to all the switches, and then destroy the one of the redundant link, and one of the port is making a block port. So when the port is in a block port, port is not in shutdown, still it is up, but it will not accept DPDU. Let me break down spanning tree algorithm. STA broken down in S. First, first is root bridge selection. First is root bridge selection. So first step is root bridge selection. Wow. So what switch does when switch is powered on? As I said, it try to find the root bridge, and then once the root bridge election is done, so switch declare among all the switches one would be the spanning tree root bridge. If you see in the configuration, I can show you switch one is the bridge is the root. This bridge is the root. This bridge is the root. This means this switch one is declaring itself I am a root bridge. If you see in spanning tree, sorry, if you see on a switch 2, there is nothing. It is a non-root bridge switch. It's a neighbor switch of the root bridge. So all switch 1, switch 2, 3, 4 are all the non-root bridge, and this is the root bridge. So root bridge election depend on the root bridge priority, root bridge ID depend on root bridge ID. I think you guys have already studied lowest bridge ID wins the election of the root bridge. Lowest bridge ID wins the election of a root bridge. Let me write in short form. Okay, so how it learns? What are the two things? What are the two factors to become a root bridge? So it is depend on two value, which is priority value, priority value, and second is a MAC address. Second is a MAC address. So these two values are very important to form a root bridge ID, and then on that basis to switch become a root bridge switch. So if I say priority value, that means there is some value which is shown here in the switch. If you see root ID priority value is 32769, and see you can see there is a bridge ID. So bridge ID is the combination of let me write down here. Bridge ID combination of a priority value and MAC address. So this is the first thing switch does. Depend on the priority value MAC address, it finds the bridge ID. Bridge ID is nothing. It's a combination of priority value plus the MAC address. If you see in the configuration here, we can see this is a bridge ID is a priority 32769 is the priority value and address is a MAC address. Let me note down this address for you. So this is the MAC address switch 1. So as you guys, I'm using in this, AVNG. So each switch has a very well-known kind of, MAC address. I hope so. Switch 2 will have a something like this. Switch A, this is the MAC address of the switch 2. Just let me put here for the understanding of the calculation of STP. Switch 2, and I'm sure this is a switch 3000 with using default values 327768. This is default value of this switch, and I'm sure this switch has a MAC address of 4000, last digit 4000, because this is a default behavior of this IS of the switches in EMG when we are using. So if you see here, the same MAC address will be there. As I said, AABB 4 dot. Okay, so on the basis of two value, priority value and the MAC address, it does the election of bridge ID. So how switch is going to be a bridge ID? If you see the priority value of this switch is switch 1 32769, 32769. Okay. Priority is 32769. So all switch has a identical priority. All switch has a 3277 as a priority value. So this priority goes tied when the priority value is equal. When the priority value of all the switches are equal, then election goes on the lower MAC address of the switch. I hope everybody is aware about this. So among all the switches, which switch has a lower value? If you can see, switch 1 has 1000, switch 2 is 2000, switch 3 is 3000, switch 4 is 4000. So the lowest value of the switch 1 is the lowest value. That's how spanning tree calculate, and it declare was, all the priority values, try every priority value is 32769, but I have the lower MAC address, so I am going to be a root bridge. I hope is it fine, right? To understand? Am I making sense to you guys? Hello, Brando, Albert. Is it fine? Hello, Gurujit. Yeah, yeah.
Yes, you're making sense.
Yes, that's good. Okay. Now, once switch does the root bridge election, what is the next value? What is the second thing? What is the second step? So first step is root bridge ID election. Second, root port election. Root port election. What is this now? So root port election. If you see, all switches are connected to each other, and now here switch 1 is spanning tree root bridge switch, and STP runs for only for VLAN. Let me show you. If you see, spanning tree instance only run for the VLAN only. Spanning tree VLAN 1. So as soon as I create another VLAN, as soon as I create another VLAN, STP work for the VLAN. So because it's a PVST mode of the Cisco switch, it's per VLAN spanning tree. That is the beauty. This is the beauty of the PVST. Let me show you. For example, I'm just creating a VLAN 10 exit. As soon as I created VLAN 10, let me show you VLAN 10 spanning tree. See, it quickly does the calculation. Oh no, what is the difference? Can you see this? What is the value of this 32778? How this value came here? If you see spanning tree villain one, the calculation is 32769. If you see the value is 32778, let me write down here. So value of this is villain one. Wait, let me go to spanning tree here. Let me write it here. Sorry, my topic is very bad. Let me write this. So VLAN 1 priority value is 32769. Switch automatically calculate this value for VLAN 1. So we created another VLAN 10. VLAN 10 switch calculate 32778. Let me show you here. That's quite okay. Now, as everybody is aware, the priority value is default priority values of switches is default priority value is 3276 and we created a VLAN 10. So when we created a VLAN 10, this 10, can you see this 10? Let me show you in the configuration. This 10 is here. This is system ID extension. Can you see system ID extension? This is a VLAN ID. This is a VLAN ID which combine to default priority value and it makes the complete value 32778. So combination of the priority plus MAC address is the total value of the priority. So here this value become once it is add it's add here VLAN 10 and it does the calculation 32778. Is this fine for everyone? If I create one other VLAN 20, so what it does? It will add 20 and make the calculation. See, now the calculation is changed. See, I added 2, this value got changed here. So this is how switch is doing calculation of priority value. Is this fine, Albert, Brando, Gurujit? This calculation is fine?
Yes.
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 Okay, great. Now, once the calculation is done, so as per the second process, now root port. Now let me tell you the root port. So once this switch one become a root bridge, root bridge, then the calculation will become for the root port. Now here post becoming this root bridge, each root bridge will send a BPU to this neighbor router. Sorry, switch, neighbor switch. This will go here, it will send BPD here, it will send BPD here because it is connected to every switch. But root port formed only non-root bridge switch. Let me write here. Connection. Port formed only on non-root bridge switches. Root port formed only not non-root bridge switches. So what is the criteria for election of root port? What is the criteria of election of the root port? So root port calculated based on the least cumulative path cost to the root bridge. So the lowest path cost to the root bridge switch. If you see for switch 2, the BPDO going in this way from this direction to this to this. This is the first direction. Second, this is going to like this, second direction, and this is the third direction. So can you tell me which is the lowest direction for switch 2? If you see, this link is very closest to the root bridge. This link, this path is very closest to the root bridge. So as I said, path cost. Now what is the path cost? We need to understand the path cost. How switch know the path cost? If you see in the spanning tree, can you see this cost is defining here 100? you see the cost is same for each villain because it's the cost of the this cost is the physical link of the switches. So physical link means Ethernet switches. If you see, so I'm just mentioning the taking the cost